Hello, in this video I'm going to be doing an example problem that incorporates both Dalton's law and the combined gas law. Question 3 is one such problem. It says a 54 ml sample of oxygen is collected over water at 25 degrees Celsius and 770.0 torque pressure. What is the volume of the dry gas at STP, which is standard temperature and pressure? Alright, so looking at this problem, we got volume, temperature, and pressure. Right away it's probably going to be the combined gas law because it has all three. We're looking for volume 2 of the dry gas at new temperature and pressure. Alright, so what I do first is I have my volume 1, my temperature 1, and my pressure 1. I just write what those guys are. So my volume 1 is 54.0 mil. My temperature 1 is 23 Celsius. But remember, for all gas laws, our temperature needs to be in Kelvin, so we're going to add 273 to that. Let's get my calculator out that I always bring to class, because I'm a prepared chemistry student. 23 plus 273 gives me 296. Alright, and then pressure 1 is 770 torr, 0.0. Then I have my volume 2, because remember my combined gas law is P1V1 over T1 equals P2V2 over T2. Volume 2 is what I'm looking for. Temperature 2 in standard temperature and pressure is always 273 Kelvin. And my pressure 2 at STP is 760 torr. Those numbers are just memorized, standard temperature and pressure. Alright, looking at this, my pressure is not totally correct right here. This is my total pressure, but I want to find what the volume is of just the pure oxygen, not the oxygen mixed with water vapor, because there's going to be some water vapor mixed in here. So I got to find my P1 using Dalton's law, which is the total pressure equals the sum of the partial pressures. And I'm not sure what my pressure of the oxygen is, but I do know my water vapor pressure is 21.1 torr. And I know that because at 23 degrees Celsius it's 21.1 torr according to what they told me. If I don't believe that, I can always go to my water vapor pressure chart, and at 23 degrees Celsius it's 21.1 torr, or mmHg, because they're both equivalent values. And that's exactly what they told me here. So, that's that. I'm just going to do simple algebra. 21 minus 21.1 minus 21.1 on both sides. So we got 770 minus 21.1. 748.9. Alright, that's the pressure of my partial pressure of my O2 gas. Not that guy, it's 748.9 torr. Alright, now what I can do is start solving my volume 1, or P1V1, so 748.9 torr, times my V1, 54.0 mil, divided by 296 Kelvin, equals my pressure 2, which is 760 torr, times my V2, which is what I'm looking for, divided by my temperature 2, which is 273 Kelvin. Right now there's multiple ways to solve this. I choose the cross multiplication way because that's my personal favorite. So I'm going to take 748.9, times it by 54, and times it by 273. It gives me this huge number. So it's like 11,040,283.8. And now I'm going to do the other side. 296 times 760 times V2 gives me 224960 V2. And I want to isolate V2, so I divide both sides by that number. 224,960. Divide both sides. Right, 11 0.040283.8 divided by 224960 gives me 49.1. And we're talking about V2. My V1 was in milliliters, so therefore my V2 needs to also be in milliliters. Started with 3 sig figs. Oh, that's wrong problem. 3 sig figs, technically 2 sig figs, 4 sig figs. So really I would have 2 sig figs in my answer. 49 milliliters would be my final answer, and that's how you solve a problem that incorporates Dalton law. My computer